1 through 5 is shorter. So let's just do 1.
Okay. Um,
Use,
what is
oh, what is the confidence interval? The confidence interval is an interval of numbers which estimates a population parameter. Now, do I understand that? That's a different story.
estimates a population? Hmm. Okay. What is the margin of error in a confidence interval when estimating the population mean? This question is not asking for the formula, but rather what length it represents in the confidence interval. What is the margin of error in a confidence interval? I like that name. When estimating the population means.
I actually understand that answer. The
The
margin of
margin
error
of error.
is half the width of the confidence interval. It is the distance between the point estimator and one of the bounds of the interval. If you have a large margin of error, then your confidence interval will also be large. If you have a smaller margin of error, you'll have a small confidence interval. And I actually got that now, so I am happy about that. That will be one of my. That will be one of the answers I actually get correct.
It seems like if you had a large confidence interval, then your margin of error would be smaller. And then if you had a small confidence interval, you'd have a larger margin of error. Or a smaller, yeah.
So if you have, so let's see, it was the confidence interval, yes?
Yeah.
No, it was the no, let's see. If you have a large margin of error, then you have a, okay. So you have a margin of error right here, right? So you're looking for the confidence interval. It would be somewhere in this line. So if you had a margin of error, it's impossible to have a confidence interval that's larger than that.
That makes sense.
Yeah. See, I understand that one. I'll get that.
Okay.
Yeah. But do you understand it?
I think so.
Okay. So I just need to remember some of the terms. Margin of error is the full margin of error contains confidence interval. There we go. Margin of error contains confidence interval. Margin of error contains confidence interval.
So it's half the width.
Yeah, it's half the width. I just say
So
what.
the other way around, the confidence interval con- contains the margin of error. Half the width. Huh. Okay. Next question.
All right. Assuming you know standard deviation, what is the general formula for a confidence interval used to estimate the population mean? X bar plus minus z score standard deviation divided by the value, or X bar plus or minus the mean.
That's important.
I like the second definition. It's a lot shorter. All right. You ready for the next one?
Just almost.
All right.
What does X bar represent?
X bar is.
It is the mean of the.
Wait, is that? Is it MU or is that just M?
Is X bar the population mean?
Yeah, X bar is like population mean, isn't it? Yeah,
So what's M?
I thought it was the mean. But I could be completely wrong.
Z-score times this standard deviation divided by the square root of the population. Or X minus M.
So is standard deviation mean different from mean?
Standard deviation mean? What are you
Yeah,
looking
like the X bar. I'm saying the standard deviation is the X bar, but is
Standard deviation is not the X bar. The standard deviation
no, standard deviation mean. There we go. Standard deviation mean.
Okay.
Sorry
What are
about
the
that.
assumptions for creating a confidence interval for a single mean with sigma known? Frankly, I'm just planning on taking this quiz, getting whatever grade that I get, and then studying more tomorrow and getting a better grade tomorrow.
Yeah, I've been reading over this assignment multiple times, especially yesterday, and I was just like, let me just fail it already.
So,
Let's just start being honest
we're
about it.
hopeless.
Hopefully I don't fit. Like, hopefully I can change that mentality of just like, hopefully I can succeed instead.
Yeah. Yeah. Please, man. Okay. What are the assumptions for creating confidence interval for a single mean with sigma known? So sigma is standard deviation. A simple random sample was drawn from the population.
The distribution of the sample mean is normally distributed, and the sigma is assumed to be known.
Didn't they already tell us that?
Yep.
Okay. Open your normal probability applets. Type in 0.90. Shade the middle area under the curve. Probability applet.
That'd be a z-score of 1.65. They also had that in the tutorial.
0.65? 1.645.
1.65.
Isn't it 1.645?
Nope, it sounded up.
Oh. They just did it. Got a different answer. So, nearest hundredth. That's why. Okay.
So next, 0.95 for the area. That would be 1.96.
$2.58.
Yep, that's a C for 0.99. And then what happens with the z-score as the area in the middle under the normal curve increases? The z-score also increases. Alright, so we went through part 1, and as promised, we shall go into group meeting. Yes?
Yeah, sure.
Alright. Oh man, all this math. I thought I was going to just read. Oh.
What?
All this math in the statistics class, I thought I was just going to read.
Yeah.
I was just being sarcastic.
Good.
Okay.
Find the margin of error.
The standard deviation is 50 and the n
Okay.
is 25. Okay, so margin of error 0.90 times
25. We don't know the mean though.
I thought the mean was 50.
No, the population size is 50.
Is it 9?
Does it say none? I missed that. Where?
I just did a different fraction thing. I did 90 times whatever.
Okay, wait, hold on.
It's
90%.
0.9. It's 0.9. 0.9. Yeah, it's 9. If I did it correctly. I just did 0.9 times 50 divided by the square root of 25.
Why?
Why is it that?
Yeah.
Well, if I'm remembering correctly, which I'm probably not, I just saw the formula and I just plugged it in.
So the formula says to find the confidence interval. Is that what you're looking at, the confidence interval?
Yeah, I think so. Wait, find the margin of error for 90% confidence interval. So I'm probably going to need that applet. Oh, yeah, I probably will. Just a second. Let me load that thing. Because I'm just going to do the 0.9, then put that into the z-score, and then that will give the standard deviation mean or whatever. And then I can import the 50 and the 25 into it as
Where are
well.
you getting the mean? How are you calculating the mean?
Well, I thought it was giving me the mean. Or whatever.
Where are you getting the mean?
Oh, I'm just following a different formula.
Wait, is that n? Is that the mean, or that's the population size, right?
Okay, so I'm going back into my individual preparation assignment to go with what I'm going with. Oh, that's what it is. Not I was totally off. My bad. Sorry if I confused you.
Okay. What? Is that symbol just cut off? It looks like an yeah. That's an n. That's population, not mean.
Yeah.
So we have the confidence interval. We have the standard deviation is 50, and then we have the thing is the population size is 25. So looking at the formula that they give us, where x bar plus or minus the z-score standard deviation over the square root of n. So I can do that first part, but how do I find? I don't know how to find either the z-score or x. So I'm missing two variables.
The z-score is 0.126.
How did you get that?
I plugged it into the normal probability applet and put 0.9 in the area, and then it gave me the z-score of what it was.
Why do I hear like tapping? Is that you?
Oh, that's it.
Tapping in the rhythm, like the tapping rhythm?
That tapping's you.
That is not me.
What? Really?
It's not me.
I wonder if the teacher's watching.
I don't think he can do that through Google Hangouts.
Unless he's unknowingly joining us.
Negative 1.64.
Negative.
0.645.
We're getting negative 1.64.
Negative 1.645. Didn't you say to type in the normal, the 0.9 into the probability applet?
Oh, yeah, I did. Oh,
So if I do that,
we just did the calculation. Okay.
then I get a z-score of 1.645 or Negative 1.645, but that
It
still
points
leaves
to
me
the
with the
nearest
question,
three
which
decimal
X-bar do
places.
we take? I have no idea how to do this problem.
Ugh. Alright, so let's see, go back to it. So X bar plus or minus the Z score, which is 0.126, with a standard
Where are you
deviation of
getting the
50.
Z-score, though?
Like I said, put in the applet.
Well, when I put it in the applet, yeah, when I put, you put 0.9 in the area? Is that what
Yep.
you're looking at?
Yep.
Shading which part?
To me, it doesn't really matter because I'm looking for the Z score. And it looks like the same on both sides. And it's changing every time I shade one area in or not. So the Z scores are remaining the same.
It's not. Okay. So if you shade in one tail,
It'll be the same.
so you have 1.126.
0.126.
I have no idea how you're getting that.
Alright, are you in your applet?
Yes.
Alright, area 0.9.
Okay, so I don't have anything shaded.
No, you want something shaded.
Okay, fine. I have left tail shaded.
Okay. So now you put it in.
Yes.
And then you have negative 0.126.
No, I get negative 0.282.
What the heck? What's going on here?
I don't know. Sometimes this thing does weird stuff.
Well, shoot. We've probably been doing math wrong this whole time. No wonder I've been getting the grades I've been getting.
I'm gonna skip that problem. I don't know.
I'm just gonna blame the aliens on that one.
You what?
I'm just gonna blame the aliens on that one.
The audience?
The aliens.
Aliens. Okay.
Aliens.
Which of the following statements is true?
MU is a point estimator of X bar. Standard deviation is an estimator of standard deviation of 2. X bar is a point estimator of MU. And okay. I'm gonna guess either C or D.
I thought it was C.
Okay, well I'm going with C then.
X bar.
Okay.
Interval is an interval of numbers which estimates the population. So is X bar the population or the confidence interval? Is that what that stands for?
I thought it was the standard deviation mean.
X bar is the standard deviation mean?
I thought it was.
Okay, then that's not accurate. I don't. Oh. Okay, I don't care.
I know it's bedtime.
Once I'm so tired today.
Well, you went to work, so that's understandable. And plus, it was your first day.
It was so long. We covered so much information. I frankly, I'm just gonna do this. Whatever I get is fine, and then I'll review it tomorrow, and I'll do better.
So you're kind of like me right now. I was just like, let me just fail it already and let me get on with my life.
Yeah.
I really shouldn't be laughing about that, but I just find that dark humor so hilarious.
Okay, so
Okay, Gina wants to construct a 95%. Okay, so 0.95 in the probability applet. That gives it 0.063.
but see where you put the shading makes all of that matter. So the 0.95 only matters if you put the shading in the right place.
0.5. Ah, now I get what you're talking about. Okay, I got you. Shoot. Okay. I'm gonna shade in the right. Wait. I got a better idea. Gina wants to construct a 95% confidence interval for GMAT scores. So I'm guessing all of it.
All of what?
Oh, I can't do that. Never mind.
You shade the entire thing?
I did. And it worked. But I did shade the center and the right-hand side, and I got 1.645.
Okay. I think you're just okay. Okay.
At least I'm trying here.
Yeah, sure. Yeah.
I might be failing, but at least I'm trying.
Okay. I
Okay, so
X bar. I feel like X bar gets a new definition every lesson.
I was just trying to keep it constant. I
No,
thought,
I feel like they give X bar a new definition every time we learn about it.
and if they do, then I just say thanks. Thanks a lot. You are very helpful. All right. Anyways,
X bar
so
in this case is the population mean.
population.
So population mean is a point estimator of the mean. Or no, sorry. X bar is the sample mean. So is X bar a point estimator of the mean of the population mean? Is the sample mean a point estimator of the population mean? Is the population mean a point estimator of the sample mean? I don't think so. Interval estimator. I don't even know. I'm so tired. I'm sorry. I'm no help tonight, and I'm not gonna be. I'm just gonna guess on everything and go to bed.
I'm just gonna say 8.105.
For 5, 8.
8.105.
5. Okay.
I did not put in the X bar equation, but I did put in the standard deviation, z-score, standard deviation, and the population.
Okay.
What is the lower limit of these confidence intervals? I do not know. How about the left? I'm going to say negative 8. Right. That's probably not it. No, it's not.
Okay. What would happen to the width of the confidence interval if Gina increased the population size? It would increase, because that sounds right. What would happen to the width of the confidence interval if Gina changed it to a 99% increase?
It would increase? Wait,
Hi.
what would happen? Wait, which one are you on?
8 and 9. Or no, sorry, 9, 7 and 9. 7 and 8. 7 and 8.
You're okay. You are tired.
Yeah.
All right. So what would happen if the width of the confidence interval, if Gina increased the sample size? It would increase. What would happen if the width of the confidence changed to a 99% confidence interval? It would also increase. Done.
Yeah.
I'm pretty confident with those answers.
Me too.
All right. A bright bulb light bulb company is planning a study to assess the average. Oh, that's what that word is. The average life expectancy of their light bulbs. They know the standard deviation is 400 hours. They want a 95% confidence interval with a margin of error of 50 hours. Shoot.
I'm in the middle of the meeting. Thank you. Brian, I'm done.
Okay.
I just put 7, 7, and 9 in for 9, 10, 11. I'll be more helpful on Thursday, I promise.
Okay.
All right. Good night.
All right. Good night, man.
Good luck. I'm sorry.
Yep. Not all about it.
All right. Later.
Bye.